So here we're going to talk about what is and why polymorphism, and we'll talk about 3 different examples of polymorphism in Java programs, and we'll talk about 3 forms of polymorphism. So what is polymorphism? So if you take a look at the definition of polymorphism in dictionary, you will actually see something like this. Polymorphism refers to the ability to appear in many forms. Okay, so that's sort of a dictionary general description of polymorphism. Now, polymorphism in Java program typically refers to an ability of a reference variable to change behavior according to what the object instance is referring to. So we have actually talked about the reference type many times today, right? I mean, we use the term reference type. So that reference type could be a superclass or it could be interface type. But what it's pointing to is an actual object instance, right? So depending on what that object instance is, that object instance's implementation will be invoked. Okay? So we'll see an example in a few minutes. So if you don't understand what I'm talking about, that's perfectly fine. So basically this allows objects of different subclasses to be treated as objects of single superclass while automatically selecting proper methods of those subclasses to be applied on a particular okay, or to be executed. Okay, so again, I'm going to explain this one again using example. So if you don't understand what I said on this slide, that's fine. So examples. So let's say we have a parent class called shape. Okay, and it has child classes circle, rectangle, and triangle. Now, shape parent class has compute area method. Okay. Now, each of these child classes, circle, rectangle, and triangle, have their own implementation of compute area method because they do use different schemes for computing area, right? So circle has to use the radius to compute its area, and rectangle has to multiply length and width and things like that, right? So the computation of compute area are different for these subchild classes. Okay, so these subchild classes will provide overloaded compute area method of shape parent class. Okay, so each of these child class will overload is there overload or override? I get confused myself sometimes. Okay, so it's providing its own implementation of the compute area method. Okay, so polymorphism enables programmers to provide different implementation of this compute area method for any number of child classes of this shape parent class. Okay, so no matter what the shape of an object is, okay, the subclass's compute area method will be used. Okay, even though you are actually using compute area method of shape reference type, because even though you're using shape reference type, the actual object instance is pointing to is going to be either is one of those subchild class objects, circle, rectangle, or triangle. Okay, and based on what object instance it is, the correct version of compute area will be invoked. Okay, so again, we'll see examples. Let's see examples of polymorphic behavior in Java programs. So we're going to actually use a very simple example here. So let's say we have a parent class called a person, and then we have student child class, and we have employee child class. So person class has a getName method. Okay, so and then Yeah, so it's not overloading, it's overriding this method in child classes. Student and employee, the child classes or subclasses, will provide its own method, which is overriding the parent getName method. Okay, so here student provide getName implementation overriding getName method of the person superclass, parent class, and it says student name. For employee, it will override a person class's getName method, and it's gonna provide its own implementation. So student implementation is different from employee implementation, and of course these two implementations are different from person's implementation of getName. Okay, so now let's see how polymorphic behavior works. Okay, so here we are going to create student object and employee object. Okay, now we assign student object into person reference type. Okay, so this is person reference type. So remember, we could use as a reference type its own type like a student object or its parent class. This is a case that we are using parent class, or you can even use abstract class and interface, which we're going to take a look later on. For now, it's using its super parent class. Okay, now by using parent class's reference type, if I call getName, what happens at this point is Java will take a look at what object instance this reference type is pointing to. It is actually pointing to student object instance, right? So it's going to take a look at whether student object has in fact a getName method implementation, and if it does, that's what it's going to call. So in this case, the name is going to be student name. Okay, now if you actually created employee object, and we create employee object. Now if you assign employee object to the same reference type variable, okay, so again this reference person is person reference type, right? So now this reference type variable is pointing to employee object. So now when you are calling getName method of this reference type, the method that is going to call is not going to be person class's getName method. It's not going to be student the getName method. It's going to be employee object getName method, because this reference type is pointing to that employee object. Okay, so this is a code, so complete code. So we created a student object and we created employee object, and then reference type is a person type, and here when we call the getName method, we are going to display the getName. We are going to call getName method of the student, and here it's going to call the getName method of the employee. Okay, all right, so let me actually go back to the beginning of the presentation. So now you should be able to understand what polymorphic behavior is all about. Okay, so I said polymorphism in a Java program is the ability of a reference variable to change behavior according to what object instance is referring to. So example we have seen is that the reference person variable, depending on what is actually pointing to, what object instance it is pointing to, different behavior will be provided or executed. Different method will be executed. Okay, so this allows objects of different subclasses, in our case student and employee subclasses, to be treated as objects of single superclass, like a person class. So what it means is that we are using a person reference type. Okay, but it's actually, it knows, the reference type variable knows what object is referring to, and depending on what object it is, whether it's an employee object or a person object, it will invoke person object getName method and employee object getName method. Okay, so hopefully now you understand what I mean by this this slide. Okay, so this is pretty much the same example. So in this case, shape is a parent class, and now we have three different implementations. I'm sorry, three different the child classes, and the shape will have a compute area, and each of these child classes will provide its own version of compute area because they have to actually compute different way, right? And now when you are using reference type of shape, shape reference type, depending on what shape reference type variable is pointing to, different computation logic will be used to compute area. Okay? All right, so that's basically what I'm talking about here. Okay, so that is the case. Now, example number 2. Now, what we have done is that we were actually using assignment, right? But this polymorphic behavior will work on message, the object passing to a method as well. So here we have a print information method which takes the person object. And in this code, it's going to call getName method of this person object. Okay? Now, depending on what object it is in fact being pointed to, it will call the different getName method. Okay? So in this case, let's say right here, when you are passing student object to print information code that we have seen here, okay, it's receiving the student object in the type of person reference type, right? But because it's pointing to, in this case, student object, it will call student classes getName method. In this case, when it's passing employee object to this print information method, again, it's actually being referenced with a person the parent class type, but is actually pointing to employee object, right? So employee object getName method will be invoked. Okay, all right. Now you understand at least the mechanics of polymorphism. Okay, so just to summarize the mechanics of polymorphism, a reference variable type. Okay, depending on what object instance is going to pointing to, it will take the actual method of that object instance rather than its own. Okay, so that is a mechanics of polymorphism. So now, what is the big deal of this? What is the benefit of this polymorphic behavior? So there are a few benefits. First, if you need to write code that deals with a family of subtypes, okay, so for example, compute area is a good example. Compute area, you want actually compute area of multiple shapes like a circle, rectangle, triangle, and things like that. And basically you can actually use your parent classes method, okay, your parent classes type, okay, but depending on what object is being assigned, okay, depending on what object instance is actually pointing to, different code implementation could be actually used. So if you need to write code that deals with a family of subtypes, the code can ignore type-specific details and just interact with the base type of the family. So your code is gonna just deal with the shape class rather than the circle class or the rectangle class and things like that. So basically you are working with a high-level abstraction class. Okay, so I mean the code is, I'm talking about this code. You don't have to actually write code to take the rectangle object or a circle object and things like that. You can actually write a very simple method like this that take the person object, and then you can just call the method of this reference type, but the actual object instances method will be invoked, meaning different implementation of it will be invoked. So this is an example where you are writing very high-level code in very simple manner. Okay. Otherwise, you have to actually provide a different logic. You actually, depending on what object is actually being received, you have to actually compute differently, and that is actually quite a bit of chore. Okay. Now, even second bullet, even though code thinks it's using an object of the base class, the object class could actually be the base class or any one of the subclasses. Okay, so this is actually more or less the kind of explain the mechanics, right? Yeah, And this makes your code easier to write and easier to read for other people. Okay, so basically it provides a simplicity. Another benefit is, so basically all this, the things I mentioned on this page is providing simplicity. Okay. Another benefit of polymorphism is extensibility. Now, you could actually write a code. You could write a code today that actually computes just, let's say, circle and triangle and rectangle. But tomorrow you're gonna actually add another shape, octagon or something like that. Okay. Now, your existing code do not really have to change because your existing code is actually working with your parent class, like a shape class. Okay. All you have to do is basically providing the compute area method implementation of the new shape. In this is octagon. Okay. So basically the extensibility is a lot easier by leveraging polymorphism. Okay. Okay, so we talk about the mechanics as well as benefits of polymorphism. So now in Java, you could actually implement polymorphic behavior in 3 different forms. The example that we have seen is actually using method overriding. Okay, so basically methods of subclass override the methods of, the methods of subclass override the methods of superclass. Okay, so this is an example that we have seen so far. Okay, like a person and employee and student. Now, scheme number 2 is that you could actually use abstract method. Okay, so the parent type is going to be abstract class, in which it actually has a set of abstract method, and then subclasses will implement those abstract methods of abstract class. Okay, so that's scheme number 2. Scheme number 3 is basically using interface. So in this case, the reference type is going to be interface. Okay, but the actual implementation is coming from the implementation classes of that interface. Okay, so you could actually have a polymorphic behavior in 3 different forms, but the most popular form of polymorphic implementation, polymorphic examples could be from using interface. Okay, all right, so this is scheme number 1. Here we are actually using the class. Okay, so this is the same example that we have seen. So we have the student object and employee object, and then we are using superclass, the parent class, person class. So person class has a getName method, right? And then student and employee, both of those child classes have their own getName implementation. So depending on what object is actually pointing to, this method calling getName will actually will use that sub-child classes object getName method implementation. So this is the scheme number 1 where we are overriding parent class. Okay. Okay, so let's take a look at example 1. Okay, so example 1 is using the method overloading, and example 2 is using abstract class, and example 3 is using Java interface. So we are basically using the same example code, but using different scheme. So the sample application is online shopping application. Okay, so here what we want to do is we are going to we're going to have a parent class, and then we are going to have a child subclasses. So there is a book class, okay, and then we are going to add children book and cartoon subclasses. Okay, so let's take a look at the code. So here we are basically so when you run this application, it's going to display each item. Okay, now each item has a different sale price. I mean different sale price percentage. Okay, so we want to actually display the actual type. Okay, so here you can see we have 2 TVs, and we have 1 MP3 player, and we have a book. Okay, and regular price is this, and the sale price is this. So basically, depending on the item, we want to provide different discounting scheme. Okay, so each subclass will implement different discounting scheme, so like we're using different percentage of discount. Okay, so now if you take a look at the code, this is the product. So this is a parent class. So parent class has compute sale price method. Okay, so it does not return any meaningful value because we know we are going to actually override this method. Okay, so it just returns 0. Okay, so we have to return something because it has to return double type. Okay, so this is the product, the parent class. Okay, and this compute sale price is going to be overwritten by subclasses because depending on the product. So the product that we are talking about is a book. So book will actually use a 50% discount the rate. Okay, so compute sale price of this book class will use 50% discount rate. Okay, while electronics we are going to use 60%. Well, actually 40% because we are actually returning sale price is actually 60% of the regular price. So we are actually giving 40% discount on electronics device. So basically, depending on the subclass, meaning different product type, subclass type, we are actually applying different discount rate. Okay, and for TV, we are going to give just 20%. So we're going to actually multiply by 0.8. Okay. All right, now let's modify the code in children's book and cartoon. So here, so children's book is going to actually have a 70% discount. Okay, so we actually have a 4 different cartoon. So we have in fact the 5 different product type. Okay. Okay. So in this case, the cartoon is actually type of book. So we actually have so book is from the product, right? And the children book is from the book. So we actually having 2 level of inheritance. Okay. So this guy is actually providing his own implementation of compute sale price, which is a 70%. Cartoon is also providing his own compute sale price, which is actually providing 60% discount. So now in main program, so let's say we have an array. Okay, so we have a product array. So the first item is TV, and the next item is also TV, and then we have MP3 player, and we have a book, and we have a book, and children's book, and cartoon like this. Okay. Well, the thing is this. Okay, so we run the application. Later on, when you are adding, so if you take a look at the code, basically we have 5 items, and then we are just kind of applying we actually calling compute price, right? Okay, and then we also actually compute the total price as well. Okay, this is the logic that we use the total price, and then we are going to display the sale price of each item. Okay. Sorry about that. Okay. Now the thing is, when we want to add another type of books like a children's book or a cartoon book, all you have to do is just add this to this array object. Okay. The existing logic. So this is the existing logic. This existing logic do not have to be changed just because you're actually adding another type. So your exercise is going to be you add another child class of maybe TV or from book or from cartoon, and see whether you can actually get the total price computed without actually changing this code. Okay, and so that is the exercise. All right, so I'll give you guys 15 minutes to do this exercise. On to the next. So next is scheme number 2, in which we are going to use abstract method of an abstract class for implementing this polymorphic behavior. So instead of using person superclass, we are going to use person abstract class. So here, getName method is going to be abstract class. The getName is going to be abstract method. Okay, so that's in fact the only difference between scheme 1 and scheme 2. So let's take a look at the scheme 2. So it works exactly the same, but the difference is, again, instead of having concrete method implementation, we create product as abstract class, and we have abstract method. Okay, and then the child class will extend that product and provide implementation of those abstract methods. Everything else remain the same. Okay, so again, you can run the application, then you can add things, and it works pretty much the same. Okay, so I'll give you guys yeah, why don't I actually finish up the last one. Okay, and then let you guys have maybe 10 minutes to finish exercise 2 and 3. So the last scheme is using interface. Okay, so this is probably more common than the other two. So here we have used the person interface. Okay, so this person interface should have a method, compute sale price method. Okay, so that's pretty much all there is to it. Okay, so if you actually go to exercise 3, everything is the same, but now product, we have to actually implement product interface. And then we have 3 methods in this interface, and then we have provide. So this is the implementation class, and this is the product interface class. Product interface, and this is product, okay, which implements product interface. Okay, now it has provide all the implementation, including compute price. Okay, and then the book extends product, and it overrides the method. And for the case, yeah, so this is book interface, and then we have implementation class. Okay, and then it does provide its own implementation of the compute sale price. Okay, so you can see, among the 3 schemes, basically idea is that you are going to implement the subclass, or the implementation class will provide the actual logic of computing sale price. Okay, so that is the end of polymorphic behavior. So let me